Hello, my name is Hayrunisa Tutuk, and I am a student in the Industrial Engineering Department. This is my Physics 101 project. In this project, I aim to demonstrate that circular motion is affected by the inclination angle of the plane, and that both the kinetic energy and the centripetal force increase as the angle increases. To perform the experiment, I used an airtable and its accessories. I measured the radius of the circular motion of the object using a ruler and determined the mass of the object using a dynamometer. Additionally, I used a block to incline the surface and measured the angle of inclination with a protractor. To measure the centripetal force, I first used the formula F centripetal force is equal to m times v squared divided by r by calculating the instantaneous velocity. Then I compared it with a theoretical value using the normal force and the formula F normal force is equal to mg tan theta to relate the experiment to theory. During the experiment, I used a mechanism that marked the points every 0.05 seconds. I first conducted the experiment at 0 angle inclination and then repeated it at 5 and 10 angle inclinations. To calculate the velocity, I measured the distance between the points and used an angle of 180 to determine the instantaneous velocity at the highest point. I selected this point to show the relationship between the velocity, centripetal force, kinetic energy, and inclination. Before conducting the main experiment, I practiced the launching process several times to ensure consistency. While keeping the path length and the mass of the object constant, changing the inclination angles caused variations in the centripetal force, kinetic energy, and velocity. As shown in the table, I also calculated the error percentages. These errors arose from the differences between the theoretical and experimental values. Furthermore, as stated at the beginning of the experiment, I plotted graphs showing that both centripetal force and kinetic energy increase as the inclination angle increases. These graphs clearly illustrate the relationship between the angle of the plane and the dynamic behavior of the circular motion.